Okay, in this video I'm going to go over how to solve some different types of inequalities. So for example, when you have a rational function or fractional function on one side of your inequality, or when you have a power that's greater than, when your largest power is greater than 2 with one of your equations. So we're going to start off with this one. For both of these, just in case you're taking notes, you just want to graph these like normal. So you're not going to change anything about these two functions. I'm going to start off with this one first. I'm just going to graph x plus 5 divided by x minus 2. You want your graphing calculator out or a delta math graphing calculator, and I'm going to plot this here. So x plus 5, that's going to go in parentheses, divided by an x minus 2. I'm just going to double check that that's what I should have graphed, x plus 5 over x minus 2. And I'm looking for where this function is less than 0, which is where my y values are going to be 0 on my, where my y values are going to be less than 0 on my graph. So I'm going to go ahead and plot this graph. And so I can see that my graph is less than 0, probably around this point right here, around -5. Then it goes less than 0, less than 0, less than 0, until, I don't know, around 2. And then at 2, it kind of does this weird thing. We call it an asymptote, where I've got this line that I can't touch on my graph. And so after 2, everything after 2 becomes positive. And it doesn't look like I'm going to cross my x-axis again. But when x is less than 2, then my function's getting more and more negative. And that's because of this asymptote, because I've got a 0, that's where I'm going to get a 0 in my denominator. So I'm going to start off really quickly just solving this, solving for this 0. So I'm going to do function zeros. I've got to find a left bound, so I'm going to go to the left of the 0. That point is fine. Then to the right. That's great. And then I'm going to guess. And I'll get that I've got a 0 at -5. So my graph starts to be negative. My y values start to be negative when x is equal to -5. So going back to that problem, if I'm putting this into interval notation, I'm going to start at -5. And because -5 gets, or there's a less than sign, not less than or equal to, -5 is going to get parentheses, not brackets. Then, like I said before, looking back at this graph, my graph is negative. But if I zoom out even more, so if I go, let's say to -50, you can see that this line is getting closer and closer and closer to 2. My x values are getting closer and closer and closer to 2, but they're never actually going to touch 2. And so it's going to be negative until 2, and then it becomes positive. And it makes a jump because of that asymptote. So it's going to be negative until 2. And that's just going to be my second bound. Because it can't equal 2, I've got that asymptote. Whenever you have an asymptote with your graph, your asymptote value is always going to get parentheses, not brackets. And so my solutions to this inequality would be parentheses -5, comma 2, close parentheses. Okay, let's look at the second one. Again, I'm going to graph this like normal, so I'm just going to type in this equation as it is. I've got x to the 5th plus 3x squared minus 4x minus 2. And so I'm going to go ahead and type that in here. X to the 5th, can't remember, plus 3x squared minus 4x minus 2. So I'm going to go ahead and plot that and just reset my x and y axis. Okay, so if I look back to that inequality, I'm looking at where this graph is greater than or equal to 0. So I want to see when is my function greater than 0, or when are my y values greater than 0. And so before I do that, I kind of want to find what these 3 zeros are. It looks like my function is going to start to be greater than 0 at -2. And then it's going to start to be less than 0, or sorry, at whatever the 0 is over here. It's going to start to be less than 0 starting here. and in between these two zeros. Finding what that zero is, where my graph starts to be greater than 0. So I'm going to go to the left of that 0. That's fine. Then to the right, that's fine. And so that 0 is at negative 1.672. That's going to be where my graph starts to be greater than or equal to 0. So with my interval notation, since I've got greater than or equal to, this value is going to get brackets, negative 1.672. Okay, then I'm going to find my next 0. So this is where that interval of being greater than 0 is going to end. So I'm going to find zeros, go to the right, or sorry, to the left, that's fine. Then to the right, guess it. So my next point, and this is where that interval of being greater than or equal to 0 is going to end, is at negative 0.388 or 389. So comma negative 0.389. That value is also going to get a bracket because it can equal 0. Okay, now I've got a jump, so I'm going to put a U. Well, from here to here, it's going to be less than 0. But then over here, at whatever this 0 is, that's when it starts to be greater than 0, and then it's always going to be greater than 0. So I've got to find that 0 first. Let's figure out what it is. I'm going to find a point to the left, point to the right. So it's going to start to be greater than 0 at 1.199. That's going to be my starting interval. Again with brackets, since it can be equal to 0, 1.199, sorry about that, 1.199, comma, and then at this point, because it just keeps on going up, my x values are going to keep getting larger and larger. So at 2, I'm going to be in the positive in the shaded range of my graph. And so it's going to keep getting larger, so I'm going to, or my x values are going to infinity. And infinity gets a parentheses. This would be my set of solutions to this graph. And that's how you're going to graph these two inequalities and find their solutions. Just graph them like normal, don't change anything.